In this video, you will learn how to solve a pair of simultaneous linear equations. This is a past paper question, and so we want to know how we solve this. So, here we have the two equations, and we're asked to write the equations in the form of ax equal b, where ax and b are matrices. Now, the matrix equation is given by a times x equal b. There are three matrices. A represents the coefficient matrix. The coefficient matrix, meaning that you're going to take the coefficients of the variable and place them in this matrix, a 2 by 2 matrix. We're going to put 5. We're going to take the minus 2 as negative 2. We're going to take the 6, put it here. Then we're going to take the minus 1, because this is a 1 right here. You don't see it, but it's a minus 1. Minus 1y. And we'll enter it as a negative 1. Again, the minus 2, enter it as negative 2. And the minus 1, we enter it as negative 1. So that will be the coefficient matrix. That's A. We can write a little a above, capital A. Then we're going to write the X matrix, or what we call the variable matrix, given by capital X. And the variables that we have in both equations are y, x, and y. And B represents the constant matrix. Those are the two numbers at the end of both equations, 12 and 13. And that's it for 2 marks. Let's go to the next part of the question. We're asked to calculate the determinant of the matrix A. Now you should note that to find the determinant of a matrix, let's say we have a matrix called, let's say called P. And these are the entries or the elements of the matrix A, B, C, and D. To find the determinant of matrix P, what we do, we multiply the A times D minus the B times C. And the answer we get should be a number. It's not a matrix, just a constant. So to find the determinant of this matrix, we do the same thing that we did with these entries for matrix P. This is only the format to find the determinant. These poles represent what? The determinant. So the determinant of matrix A, which we can write it as this, determinant of matrix A, 2 straight lines, equal, we're going to multiply 5 times negative 1, and that will be what? Negative 5. Then we put minus negative 2 times 6. What's negative 2 times 6? That's negative 12. And now, what do we do? What do we do with these two here? We recognize subtracting the negative is really a plus. And so this is actually negative 5 plus 12, which is same as saying 12 minus 5, which is 7. So the determinant of matrix A is 7. Next question, part B. We're asked to show that the inverse of the matrix A is actually this 2 by 2 matrix. We have 2 rows and 2 columns. So first, in order for us to find the inverse of matrix A, we need to know what matrix A is. So we need to go and take or rewrite matrix A. So matrix A is 5, negative 2, 6, and negative 1. In pair brackets, so we have 5, negative 2, 6, and negative 1. And we need to show that the inverse of this matrix is this. So remember, how do we find the inverse of a matrix? Well, let's go back to matrix P again. So here we have matrix P. And it's given by the 2 by 2 matrix with components A, B, C, and D. To find the inverse of matrix P, which can be written as P inverse, we put 1 over the determinant of matrix P multiplied by the adjoint matrix. of P. P adjoint or adjoint of P. And this will be the inverse. So let's do the same thing with matrix A. We're going to put, let's go, in A inverse equal 1 divided by the determinant of P in this case for the format. So we're going to find the determinant of matrix A. What is the determinant of matrix A? We actually found that earlier. The determinant of matrix A is actually 7. So we just need to just enter it here. Then we're going to multiply by the adjoint of that same matrix. So the matrix we're dealing with is A, so we're going to find the adjoint of that matrix. Now, how do we find the adjoint of a matrix? So that's the key question. How do we find the adjoint of a matrix? So let's go back to matrix P to find the adjoint. So what we can do, we can extend this and write it as 1 over the determinant, which is A times D, which is AD, minus B times C, which is BC, multiplied by the adjoint. So again, A times D minus B times C will give us the determinant. We put it under 1 in the denominator, times the adjoint matrix. Now the adjoint matrix is basically a 2 by 2 matrix. And what we really do, we actually switch. We switch these entries. A becomes D, D becomes A. In other words, they go into each other's position. So we're going to have D here. We're going to have A down here. But what happened to B and C? What happened to the B and C? Do we switch them? No. But instead we multiply them by -1. So we're going to multiply B by -1. We get negative B. Multiply C by -1. We get negative C. And this is the inverse of matrix P. 1 over the determinant times the adjoint matrix. And the adjoint matrix is found by switching A and D, the entries of the leading diagonal, and keeping the entries of the non-leading diagonal in their place, but instead we multiply them by -1. We change their signs, in other words. And so what we're going to see here for the adjoint matrix, remember we have the 1 over the determinant already. We're going to switch these guys. 1, -1 goes here, and 5 goes here. We basically switch them according to the format for the adjoint matrix. We switch A and D. And what we do with B and C, keep them in their position. So we're going to keep the 6 and -2 in their position, but we're going to multiply them by -1. In other words, we're going to negate them. So -2 negated is what? -2 negated is +2, and 6 negated is -6. In other words, we multiply -2 by -1, which gives us +2. Multiply 6 by -1, and we get -6. So again, 1 over the determinant times the adjoint matrix. Now, what we recognize is that this is the inverse. However, the format that we have been given is this. There's no scalar, there's no number outside multiplying the 2 by 2 matrix. So what they really did was to multiply the number outside by the adjoint matrix. In other words, they multiply 1 over the determinant by each entry of the adjoint matrix. So let's see how they did that. Basically, they multiply 1/7 by -1. We can write this over 1, and that answer is going to be -1 over 7. So in bracket, when you multiply the scalar, which is the number outside, which is 1 over the determinant, by -1, you get -1 over 7. We can put the negative at the side and write it as -1/7. Now, 1/7 again, multiplied by 2. Put 2 over 1, and we're going to get 2 over 7. So it's going to be +2 over 7. Multiply 1 over 7 again. That's a scalar. We're distributing 1/7. Multiply it by -6. Put -6 over 1. And so we're going to get 1 times -6 is -6. And 7 times 1 is 7. So we're going to get -6 over 7. Then we're going to multiply 1/7 again by 5 over 1, which is going to give us 5 over 7. All right, if you're wondering where the 5 and the -6, where they're coming from? Coming from the adjoint matrix, these entries inside. 1 7 times negative 1, 1 7 times 2, 1 7 times negative 6, 1 7 times 5, which is 5 over 7. And let's check to see if we actually showed that A inverse is equal to this. Let's compare. Negative 1 over 7, correct. 2 over 7, correct. Negative 6 over 7, correct. And 5 over 7, correct. So let's look now at solving the two equations, or we should say the pair of simultaneous equations that we were given originally using A inverse. So recall that we would have used the pair of simultaneous equation and write them in the form of what? AX equal B. In other words, a matrix equation. We did that. So what we're going to do, we're going to write back the matrix equation. So we have the matrix equation here. We have the over here being the what? The left hand side of the equation. And over here being what? The right hand side. So we're going to multiply both sides by the inverse, A inverse. All right, so what we're doing, basically, we have the matrix equation here. And we're going to multiply this side, the left hand side, by the inverse. As you can see here, so this is the inverse multiplied by this side, as you can see down here. Then we're going to multiply this side as well. Now what we're going to do is to put, instead of putting the inverse here, we're going to put it to the left of this constant matrix. So I'm going to write it here. And this is what you're seeing here. Now, when you multiply a matrix by its inverse, so this is A, this is matrix A, and this is the inverse of matrix A. Whenever you multiply a matrix by its inverse, which can be written in any order, doesn't matter if you multiply A by A inverse or A inverse by A, you're going to end up with the identity matrix. So this will give you the identity matrix, this will give you the identity matrix. What is the identity matrix? You're going to have 1, 0, 0, 1. This is known as the identity matrix. All right, typically what you do when you have this, when you multiply this matrix by this matrix, you simply write down this matrix here as a resultant matrix. But just for you to understand, I am going to do it at the side so you can understand what's happening. So here we have, this is A inverse, which is here, and this is matrix A here. Let's multiply them. Now when you're multiplying two matrices, what do you multiply? You multiply rows by columns. So let's do that. So we're going to multiply this row by this column. When we do that, now negative 1 over 7 times 5, multiply first by the first, you can get negative 5 over 7. So you should actually know how to multiply matrices already. So you can check a video out on that and then come back to this. But this is how you multiply the 2 by 2 matrix here by the other 2 by 2 matrix. The inverse of A by A. Row by column. Negative 1 over 7 times 5 gives you negative 5 over 7. Added 2. So that's first by first, then second by second. 2 over 7 times 6 give you, that will give you 12 over 7. Okay, you can put it in your calculator. Negative 1 over 7 times 5, you get this. Added 2, must be put plus sign. 2 over 7 times 6, you're going to get this. All right, let's do the others. We're now going to multiply the same row, that's row 1, by row 2 now. Let's do that. Let's multiply row 1 by row 2. Okay, so in multiplying row 1 by row 2, what are we going to get? So we're going to have negative 1 over 7 times 2, first by first. That's going to give us positive, because negative times negative is positive, so that's positive 2 over 7. Added 2. 2 over 7 times negative 1. That's going to be negative 2 sevenths. So we finished multiplying row 1, that's row 1 here, by column 1 and column 2. So what we need to do now is to multiply. This is column 1, the symbol is column 1, and here is column 2. So we finished multiplying by row 1. Let's go down to row 2. I'm going to multiply row 2 by column 1 and column 2. So let's do that. So here we have row 2 by column 1 now. So because we're multiplying the row 2 by column 1, our answer should be in row 2 of the resultant matrix. Row 2, column 1. Just as we multiply by row 2, column 1. So it's negative 6 over 7 times 5. Negative 6 over 7 times 5 will give us negative 30 over 7. So it's be negative 30 over 7 plus second by second. So that's 5 over 7 times 6. 5 over 7 times 6 would be 6, 5, 30. 7, 1, 7. That's 30 over 7. Now we're going to multiply row 2 by column 2. And so this will give us what? Negative 6 over 7 times negative 2. First times first. So negative 6 over 7 multiplied by negative 2. Put it over 1. Negative times negative is positive. 6 2 is 12 over 7. So we're going to put 12 over 7 here. Added to what? Remember first by first, which we got 12 over 7. Now it's going to be added to second by second. So that's 5 over 7 times negative 1. And 5 over 7 times negative 1 is simply negative 5 over 7. Alright, so that's going to be the resultant matrix. Now let's simplify this. Now we have the same denominator, correct? And what we need to do is to add the numerator. So we have negative 5 plus 12. Negative 5 plus 12. Let's work out the numerator. And the answer we get, we put it over 7. Alright, so it's going to be over 7. What is this answer here? So remember, if you're adding two fractions, you keep the denominator and add the numerator. So let's work that out. In fact, I'm going to just put the answer in here. But let's work it out at the side. Negative 5 over 7 plus 12 over 7. Keep the denominator, which is 7. Add the numerators. Negative 5 plus 7. Negative 5 plus 12, that's 7. Over 7, we get 1. So the answer here for this entry is 1. 2 over 7 plus negative 2 over 7. 2 over 7 plus negative 2 over 7. This becomes minus. And 2 over 7 minus 2 over 7 will give us, of course, 0. Because you're subtracting a fraction from itself. Give it 0. Or I can say 2 minus 2 is 0. And 0 over 7 is 0. So this entry here works out to be 0. Negative 30 over 7 plus 30 over 7. Keep the denominator, which is 7. Negative 30 plus 30, that's 0. And 0 over 7 is 0 as well. So that's going to be 0 here. So you can see where this is going. And 12 over 7 plus negative 5 over 7, that's 1. If you want to do it, let's put the 7, keep the denominator. I'm going to say 12 plus negative 5. Of course, this plus negative is going to give minus. 12 minus 5 is 7 over 7, which is 1. So we got a 1 there. So what are you learning here? You are learning that, hey, when you multiply a matrix by its inverse, you get this matrix. This matrix is called the identity matrix. What kind of matrix is this called? It's called the identity matrix. The leading diagonal entries are 1, and the non-leading diagonal entries are 0. Alright? The leading diagonal entries are 1, non-leading diagonal entries are 0s. Okay, so the thing you need to understand is this. Look, you see, whenever you're given this problem to work out and you multiply both sides by the A inverse, you know that you have A here, matrix A here, and this is matrix A inverse. You do not need to show how you actually get the identity matrix. Simply do this. You have the knowledge that when you multiply a matrix by its inverse, you're going to get what? The identity matrix. Any matrix at all by its inverse will produce the identity matrix. So all you need to do is put 1, 0, 0, 1 here. That's the result of multiplying A inverse by A, or A by A inverse. Then you're going to write back the X, Y, that's the variable matrix, and you're going to multiply this. So in terms of working, this is the part that you just need to multiply, and that will be it. Just multiply out this side. Okay, for this side though, just put the identity matrix there. Don't need to go through this. But this was just proof for you to know that you'll get the identity matrix 1, 0, 0, 1. All right, so now we need to multiply the right-hand side. So we're going to have rows by columns. Let's do that again. This row by this column to get our resultant matrix. Row by column, so row 1 by column 1. What will give us? That will give us one entry. So it will be negative 1 over 7 times 12, which is going to give us what? Negative 12 over 7. So the first by first gave us negative 12 over 7. So it's negative 12 over 7 added to what? The second by second. Let's do that. That's going to be 2 over 7 times what? 2 over 7 times 13. Second by second. So first by first gave us this. Now second by second will give us what? 2 sevens times 13. That's 26 over 7. Now we keep the denominator of 7 and we subtract 12 from 26 because different signs. And that will give us what? 14. Positive because we have more positives than negative. And of course, 7 into 7 goes once, into 14 goes twice. So the answer here is 2. So when we multiply the row by the column, we get a result of 2. Again, first by first gives us negative 12 over 7. Second, added to second by second, which gives us 26 over 7. And when we work this out, we get 2. That's the result here. So now let's go down to the next row. And in row 2, we're going to multiply it by what? Row 2 by this column. So that's going to be negative 6 over 7 times 12 added to what? 5 sevenths times 13. Okay, so we need to work on that. So let's go. What is the first by the first? Negative 6 over 7 times 12. This is just side work here. And that will give us negative. Now, negative 6 times 12 is what? Now, 6 times 12 is 72. That's negative 72 over 7. Added to what? Let's work out the second part. 5 7 times 13. So let's work out 5 sevenths times 13. And this will give us what? 65. 5 times 13 is 65. Remember, 5 12s are 60. So 5 times 13, 5 more would be 65 over 7. 717. Okay, so remember, the first by first gives us negative 72 over 7. Added to the second by the second gives us 65 over 7. Keep the denominator and look at the numerator. They have different signs, so we subtract. 65 from 72, that's 7. Remember, we keep the sign of the one we have more of. We have more negatives, so it can be negative 7. Now 7 goes into 7 once, and that's going to be negative 1. So our answer here is negative 1. Alright, so you can always replay that part to see how we got these two. Now here's another concept that you need to understand. Just like when you multiply a matrix by its inverse, you get the identity matrix. When you multiply the identity matrix by any matrix, you get back that matrix. So in other words, A, let's put it over here. Matrix A multiplied by its inverse gave us what? The identity matrix. Which is the same thing as say A inverse times A. You will still get the same thing, no matter the order in which you multiply them. But here's the deal. If you multiply the identity matrix by the variable matrix, remember the variable matrix is x, you're going to get back x. Why is that? Because the identity matrix, which is this, behaves like the number 1. So it's just as saying 1 times this matrix will give us back this matrix. But let's see if that is true. Let's do it over here. 1, 0, 0, 1 multiplied by x, y. In other words, when I say x, y, I mean the matrix with components x and y. So we're going to multiply row by column, row by column. Now first by first, 1 times x gives us what? X. Plus 0 times y gives us 0. Let's go down to the next row, second row, by the first column. So we're going to say 0 times x, which would be 0, added to 1 times y, which is y. Let's add these. X plus 0 is simply x. 0 plus y is simply y. What did you notice? When we multiply by the identity matrix, we get back this matrix as the answer. So the identity matrix behaves like the number 1. So in other words, you don't need to show this working here. Based on your knowledge, you know that the identity matrix times any matrix gives you back that matrix itself. So all you got to do is to just, when you have reached this stage, just simply write this, because you know that this times this will give us this. Just like the A inverse gave you, when multiplied by A, gave you this. As you just write it down. Same thing we do with this. Let's put back the 2 and the negative 1. Now reach a stage where we use our knowledge of what? The equal matrices. Now for equal matrices, you know that when 2 matrices are equal, the corresponding entries are also equal. What that will help us with, how will that help us with this? When 2 matrices are equal, the corresponding entries are equal, which tells us that x corresponds to 2 and y corresponds to negative 1. So these are our solutions. Now how do we know our answers are correct? Well, we can always check. X is 2, y is negative 1. Let's check that. X is 2, y is negative 1. Let's double check. X equal 2, y equal negative 1. So we're going to say 5 times 2, 5 times 2, minus 2 times y, y is negative 1. Let's work that out. This is going to be 10 plus, because negative times negative is positive, 2, which gives us 12, which is what we have here. Let's try the other one. 6x minus 1y equals 13. X we found out to be 2, right? So it's 6 times 2 minus, provide this minus here, y. The value of y is negative 1. Let's see if we get 13. 6 2 is 12. Subtracting a negative, that's plus 1 here. And 12 plus 1 is indeed 13. So we can see there, that's our solution. Alright, hopefully this video has helped. If you need another example, just let me know in the comment section. I'll go through much faster since we have gone through this problem quite thoroughly. We took our time with this. Alright, all the best.